Hey, this is Miss Park. Just going to take you through the end of our 3 forms of quadratic functions booklet. We're going to look through page 4, 5, and 6. So the page 4 in the booklet talks about converting between the different forms that we have. So you see that we have the 3 forms: factored form, standard form, and vertex form. And it's just kind of recap of how do you get from one to the other. So I'm just going to, I've already filled in this page, so I'm just going to walk you through it real quick. So from factored form to standard form. So remember, factored form has something useful in it. It's got the x-intercepts that we can see. How do we get it from factored form to standard form? So you'll notice that factored form has these brackets because there's a multiplication to be done. Standard form doesn't have that. So to convert to standard form, we're just going to expand. Okay. The other one is vertex form to standard form. So here's your vertex form. We can see the vertex from it. It also has brackets, which suggest it needs to be simplified. So how do we get there? We just expand. Okay, and there's your vertex form. The third one is, how do you get from standard form to vertex form? Okay, so I want to go from something that looks like this to something that looks like this. So I want to create some kind of bracket squared. I want a square in here. Okay, so if you get an opportunity to watch my video on area models and the expression was completing the square. Okay, so last year you learned completing the square algebraically. I'm presenting to you 2 options. There's an algebraic option that's the same as last year, but there's the other one that's using area models, those rectangles that look like this, which you might find a little different, right? Visual, maybe a little bit easier. Okay, and the two procedures are very, very similar. They're actually the same, just they look different. Okay, so completing the square. So watch the video. Here, the other one is to go from standard form to factored form. So all we have to do is we got to factor. Okay, so this is, I'm factoring this here. Take out the -2, and now you have a simple trinomial. Got to find your 2 numbers that multiply to -14, add to -5. These are the 2 numbers, and so now you have it factored. And these are the x-intercepts. And again, you know, if you haven't watched the area models video from like the very beginning of the course, like from the first week of classes, then I highly suggest that you watch it. You might find using area models for expanding and for factoring is helpful to you. Okay, so I'm going to go to the next page, page 5. And so the next 2 pages focus on finding the maximum or minimum. Okay, and again, why do we want to find the maximum or minimum? It's so that if I'm giving an equation in standard form, and I say to you, okay, here's an expression for you know, profit or area or something really good I want to maximize, I want to be able to tell you what the maximum value is. And in order to know the maximum value, I need to know that vertex, right? And so if I have the standard form, I can complete the square to get to the vertex form. So here we go, I'm going to complete the square. All right, so I'm giving you this equation here in standard form. I'm going to run through the steps of last year, but I'm also going to throw in a little bit of the area model so you could see what's happening. Okay, so last year we said, I'm starting with standard form. I want to end up with something that's got a squared in here. All right, so I'll take out my a value. Okay, take out the a value because remember, we want to end with this. So I'm going to factor out this a value. So that's the -2. Let's take it out. And I'm left with -2 times x squared plus 9/2. Okay, no, I divided by -2. All right. And now what I want, I still want this thing to look like something squared. So I'm going to have to turn it into a square. So if you watch the area models, basically what I have is I have something that I have my x squared here, okay? And I want these two boxes to add up to 9 over 2x. But because I want this to be a perfect square, these dimensions have to be exactly the same. So this is an x and this is an x. These two have to add up to 9 over 2x. So I want these two numbers to add up to 9 over 2, and it has to be the same number. So it has to be half of 9 over 2. So this one has to be a 9 over 4, and this one has to be a 9 over 4. So that when I do the multiplication, to find the area here, I have 9 over 4x, and the area of this one is also 9 over 4x, and when I add them, I'm going to have my 9 over 2x. Okay, sorry, this should say x. My 9 over 2x. Okay, so that's what I want. So let's write this here. X squared plus 9 over 2x. Well, hold on a minute. If I want to write as something squared, there's an extra part in here that I have to calculate. Okay, so this extra area in here is 9 over 4 times 9 over 4, which is 181 over 16. Right. So I'm going to add that 181 over 16, which is going to give me the perfect square. Right? Problem is, I can't just add that because I've just changed the question. Right? I can't just put in an extra number that wasn't there. So let's take it away again, as if I never added it. Okay, so now this is like adding 0. So I have not changed the expression from here. Okay. Last year, what you learned is here's the b value, right? Here's your b, ax squared plus bx plus c. So here's your b is 9 over 2. You take your b divided by 2 and you square it. So b divided by 2, so 9 over 2 divided by 2 squared is 9 over 4 divided by 2, which is 81 over 16. There's that number. Sorry, did I write 181? I meant 81. 81 over 16. Okay? And I don't know why I wrote this. Okay. All right, all fixed. 81 over 16. So if you're wondering where the 81 over 16 came from that we added, it came from here. So why did we divide by 2? It's because we wanted these two numbers to add up to 9 over 2, and they also have to be the same. So that's why we took it and divided by 2. And why did we add that number squared? Because this is the part of the box that wasn't there that we have to add in order to make this a perfect square. All right, so then we have this. Then what we said last year, see this part here? This part here can be written as a perfect square. And you can see it from this box, right? So this is x plus 9 over 4 squared. Right? But we've overcounted because this 81 over 16 was never there. So we're gonna have to subtract it away again. But the only thing is we've written it in a bracket that is multiplied by -2. So I can't just subtract 81 over 16 here. I have to recognize that it's times -2. So basically what I'm going to do here is distribute this -2 to this part. So I've got it 2 times this part squared. Then -2 times -81 over 16, which is, I can actually reduce the 2 with the 16 and just get 81 over 8. And then I've got this 10. Okay, so the 2 is actually distributed to this part and also to this part. And then I've got this 10 hanging on the end. And this is x plus 9 over 4 squared. And here, I just need a common denominator. So this actually is plus 81 over 8 plus 80 over 8. All right, and then I'm done. X plus 9 over 4 squared. I'm going to add these two. I'm going to get plus 161 over 8. Okay, and so the vertex is from here, -9 over 4 and 161 over 8. Okay, what does it mean? Here's -9/4 and 161/8, wherever that is. We know it opens downwards because my -2 is the A. So since the A value is negative, so since A is less than 0, we have a maximum. This is a maximum. And now to figure out the rest of it, what's the maximum value? Well, this is the point, -9/4, 161/8. So the maximum value is 161/8. And it occurs when x is equal to -9/4. Okay, and that's that. All right, so that's completing the square. Here's a new sort of grade 11 method that you are also welcome to use, right? I'll remind you of the easiest method of finding the vertex, which we did on, I believe it was page 3, okay, which is when we were given an equation in factored form. So let's say this one. I'm asked to sketch it. So to sketch it, I need to find the vertex. And this is the absolute easiest way to find the vertex. Okay, so this is a review of page 3. Factored form tells us the intercepts. Okay, so 1 and 5. And we know that the vertex is going to sit on the axis of symmetry, which is exactly halfway between the 1 and the 5. Okay, where does it sit? Well, let's see. If I don't write y, let me write f of x, since we know function notation now. Right? I have to figure out, I know that my vertex is going to be 3 something. It's going to be on this line, 3 something. So what is the y value that you get when x is 3? In other words, what's f of 3? So let's see. It's 2 times 3 minus 1 times 3 minus 5, which is 2 times -2, which is -8. And that tells me that my vertex is down here, 3, -8. And I can sketch this. Okay. For the purpose of maximum and minimum, it tells me that the minimum value, so I know it's a minimum because it opens upward, so I know it's going to be the lowest point. So the minimum value is -8, and it occurs when x equals 3. Okay, so this is the easiest way. So the third method, which is on this last page, is called partial factoring, and it really it continues. It's a continuation of this. It's built on the fact that if you know x-intercept, you can get the vertex. Okay, so let's look at the example. Okay, so the example is this one. It's asking for the same parabola that's on the previous page that we did with complete the square, and I'll just change this to f of x. Okay, so find the maximum or minimum value of this, same question as before. Okay? And what we're going to do is we're going to remember from grade 10 that if I have y equals x squared, okay, then I can shift it up and down by adding numbers onto the end. So for example, y equals x squared plus 10 would look like this, because every y value of this will have 10 added to it. So the 0 will have 10, and when y is 1, it'll be 11, and when y is 4, it'll be 14. Right? Every y value will be increased by 10. So I'm actually shifting the parabola up. What I want to do now is take the parabola with all of this and ignore the plus 10 so that I can shift the parabola back down. And shifting it back down is going to show us something very interesting. So let me take g of x, which is the same as f of x, but without the plus 10. So g of x is f of x, but shifted down by 10. Okay? G of x only has 2 terms. So let's get this into factored form so that I can read the x-intercepts off of these 2 terms. Because remember, having x-intercepts is the easiest way to find the vertex. Okay? I can factor this. So I'm just going to remind you, this is factored form. Okay? And so if I factor it, I see there's a common factor of x. Okay? There's only 2 terms. The only thing I can do is common factor, x. But factored form also takes the a out, so that the insides they only have x's without a coefficient. So I'll also take the -2 out. So I'm going to take the -2. I'm also going to take the x, which is a common factor. And here's my other bracket that's left over. This is actually the same as y equals -2. X alone is like x minus 0. And this one here is x plus 9 over 2. This is factored form. And from this, I can see that the x-intercepts of G are 0 and -9 over 2. Okay? G, not F, not this one, but this one that's been shifted down by 10. Let me sketch what just happened. G has x-intercept 0 and -9 over 2. Okay? The axis of symmetry of G is halfway in between. We know G opens downward, so I know that the vertex of G is somewhere, and I don't know where it is. Okay, this is G of x. Now, f of x is the same as g of x, but it's been shifted up by 10, right? Because g of x, we shifted down by 10. So here's our f of x. That's 10 higher. We don't know the x-intercepts of the f of x, right? We don't know, but we actually don't care. All we need to know is that it has the same axis of symmetry as the g of x, because it just shifted up. So if we know the axis of symmetry of g of x, then we know that the vertex of f of x lies on the same line. So let's calculate the axis of symmetry here. So we're going to take the two x-intercepts, add them together, and divide by 2. And that's going to give me -9 over 4. So that means that the vertex is -9 over 4 something, right? This is -9 over 4. And we just want to figure out what's the vertex, right? We need to find the y of it. So let's do this. So the axis of symmetry is x equals -9 over 4. So the vertex of f is -9 over 4 something. Let's find the y coordinate of the vertex. So all that is finding f of -9 over 4. What's the value of f when x is -9 over 4? And that's going to be -2 times -9 over 4 squared minus 9 times -9 over 4 plus 10. And that's -2 times 81 over 16 plus 81 over 4 plus 10. I can reduce the 2 and the 16. And I have -81 over 8 plus, let's make them all over 8. 162 over 8 plus 80 over 8. And if you add all of these, you get 161 over 8. So the maximum or minimum value is 161 over 8. All right, let's put it here. 161 over 8. It occurs when x is equal to -9 over 4. And the only thing we need to do, it says maximum slash minimum. This is a maximum. We'll circle that. Okay, same vertex as the completing the square. So it's a matter of getting used to which one you like better. If you have factored form, don't use any of these methods. Use this, the one of page 3. Okay. If you have standard form, then it's your choice. Do you want to complete the square or do you want to use the partial factoring? It's just a matter of getting used to it. Let's do a quick partial factoring practice. Find the maximum or minimum value of this. Let's call this f of x, since you know function notation. So I'm going to say consider g of x, which is the same thing, but without the shifted up 5. So 4x squared minus 8x. I'm going to factor that. I will factor out the 4, and I'll take out the common factor of x. And I get x minus 2. This is the same as factored form, looking like this. Okay. Therefore, the x-intercepts are 0 and 2. Now, those are the x-intercepts of G, not of the original F. But the x-intercepts will help us to find the axis of symmetry. So the axis of symmetry is we're going to add them up and divide by 2. So x is 1, x equals 1. So, right, here's your axis of symmetry going through 1. Okay, and wherever g of x was with its intercepts at 0 and 2, f of x will share the same axis of symmetry. So therefore f of 1, let's figure out the y, is 4x squared, sorry, it's 4 times 1 squared minus 8 times 1 plus 5, which is 4 minus 8 plus 5, which is negative 4 plus 5, which is 1. Therefore, the vertex is 1, 1 of f, okay, is 1, 1. Okay, so this is 1, 1. So therefore, hold on, something happened. It should open upward. So something happened. We can find it. This happens all the time, so it's okay. So let's find it. You probably found it already, and I haven't found it. 4 minus 8 is negative 4 plus 5 is 1. But it should open upward. So F1, 4 minus 8, 4 plus 1, 5. Oh yeah, of course, because it's not, of course. There we go. Oh no, it should open upward. It should open upward. Okay, so here's what happened. F is not going to go through these, intercept. Those are the intercepts of G. Okay, I just made the classic mistake. So this is actually really good that I made this mistake. G is down here and will go through those x-intercepts. F doesn't have those x-intercepts. F is higher. So it does open upward. So the vertex of F is 1, 1. That's not the vertex of G. It's the vertex of F that I just found. So therefore, we say the minimum value is 1, and it occurs when x equals 1. Okay, and there you have it. So in the textbook, you have practice of completing the square and of partial factoring, and you're going to need to practice those before we can do our max-min problems. Okay, thank you for watching.